So when we go back to the topic functions, it really depends on a couple of basic ideas. And I want to make sure that we all have those basic ideas. And the idea behind a function is that there's some input, there's some rule or relationship, and there's some output. So, sometimes the rule could be written like 2x plus 1. And if my input was 3, what is my output going to be? Pop it in the chats. So we're just going to look at the basics. Yeah, it's just going to be a 7, hey? Because 3, the input is the x. So we can even put that here and say the input's the x, the output is the y. And if I go 2 times 3 plus 1, I get 7, let's say. And so this rule has sent 3 to 7. And that little relationship is often recorded as a coordinate pair. And we would say that coordinate pair is 3, 7, and this would be x, and this would be y. Now, what happens if I send in a different input? Let's make it -4. What is the output going to be for -4? You can pop it in the chat. So if I go 2 times -4, I get -8 plus 1, and I get -7. And so that little relationship is -4 minus 7. And we call that a coordinate pair. So when we think of functions, I mean, they are more detailed definitions, but if we think about really what's happening, there's an input, there's a relationship or some sort of rule, and there's an output. And this rule is sometimes written as the relationship between inputs and outputs, or between x and y. And we often call this, well, we call this a straight line equation. And the reason it's called a straight line equation is because it makes a straight line when you graph it, and you can recognize it when the highest power is a power of 1. Okay, of the variable anyway. Now, the other thing that we need to think about is what happens with this relationship in terms of how does it end up on what we call the Cartesian plane or a graph. And all the Cartesian plane or a graph is a representation of this relationship. So these little relationships go on the graph, but they come from the big relationship. And let me see if I can just move this down to give me a bit more space. And then we actually were doing this in the last topic, but it's good to just kind of go back to basics. If we want to illustrate this relationship, so far we know that there are 2 points that are particularly, important based on what we've done. So, well, let me just move this around. So we know that the point 3, 7 is in our relationship. So 1, 2, 3, and let's put it up here. I know it's not perfect, but say 3, 7. And the point -4, okay, I'll put it down here, like -4, -7. Now, that's only 2 points on this relationship, and I happen to know this is a straight line relationship, and so I can actually draw a straight line through these points, and the rule that we use to label these points is just going to be the one above, y equals 2x plus 1. Now, we only need 2 points to draw a straight line, but there are many other points on the straight line, and 2 particular points are quite important. So I'm going to make it the red dot and a black dot. And I want to know from someone, what is the red dot called and what is the black dot called? They have their own special names. Someone can put their hand up and they can let me know, or you can put it in the chat if you like. What's important about the red dot or the black dot? What's their special name? Come on, I know you wanna. Orokanisa, let's unmute Orokanisa.
Hi, sir.
How's it going?
I'm fine, thanks. And how are you?
Very good. What can you tell me about the red?
I just want to try. I think the red dot is for the y-intercept,
Yep,
which means
you are
x
winning
equals
at
to
life.
0. Yes. And then the
In order to
black
find the
dot is the,
y-intercept, you make x equal to 0. Did everyone hear that? So to find the y-intercept, you make x equal 0. What's the black one going to be? What's the black dot?
it's going to be the x-intercept, which means y equals to 0.
Okay, lovely. Love it. You have done your bit for the team. Now, I want to know from someone, why do we make x equal to 0 to find the y-intercept? And why do we make, does anybody know why this works? Can anyone give me like a bit of an explanation as to why this, so I want to suggest that the y-intercept always is on the y-axis, and the y-axis always is in line with where x is 0. So that's why it always works. And it works for all functions. Whenever you find, whenever you put x is 0 into an equation, it's always going to find you the y-intercept if you've got one. Whereas the x-intercept is always going to be in line with y equals 0. And so that's an important idea. Can everybody give me a thumbs up, or give me a thumbs up if you understand why for the y-intercept, x must always be 0, and for the x-intercept, y must always be 0? Just using the colors that I've just shown you. Give me a thumbs down if it's still a mystery to you. Okay. So basically what I'm saying is no matter what graph we draw, whenever you go through the x-axis, you're always in line with where the blue line goes. And whenever you go through the y-axis, you're always in line with where the yellow line goes. We call this the y-axis and the x-axis. Okay, we're almost ready for you to get going. I want to find the y-intercept. So what I do is I'm going to take the advice and I'm going to say y is equal to 2 times 0 plus 1. And so my y-intercept is just going to be 1. Or if I write it in full coordinate form, instead of just writing it as 1, you're going to write it as 0, 1. That would be the full coordinate form. And to find my x-intercept, I make y 0, and then I move the 1 across, and then I divide both sides by 2. Trying to move my Zoom thumbnails around so I can see. I get minus a half equals x, and then the full coordinate here would be that. And these are particularly important points. Whenever we draw straight lines, we normally look to find the x and y intercepts. And so that's what I wanted to do to start with today, and also to show you that there are many other points on this line, on this relationship. Now, actually, before I move on, I want somebody to tell me another point that is on the straight line. So give me another point that is on the straight line that I haven't given you already. I've given you 4 points so far. Give me a 5th one which you can work out is on the line. Maybe somebody can even put their hand up if they feel. Melly has raised their hand. Melly, I want to hear from you.
Hi, sir.
Hey.
So I was asking a question for the previous question, sir.
Okay,
you said,
go ahead.
Sir, the coordinates was negative, a half, and 0. So I was wondering,
Yes.
sir, since you said 2 times 0 plus 1, would it be positive? Wouldn't it be positive 1?
Okay, good question. So what I want to draw your attention to is, can you see the plus 1 over here?
Yes.
So if you move that across, would you agree it's negative 1 on the other side?
Yes, sir. But so I was asking the one for y, sir, not x.
Oh, for y. Okay. So for y, what happens is that you look at that 0, because can you see you have x is 0 and it goes here? Oh, that's not a good
Yes,
color. So now 2 times 0 is actually going to be nothing.
Yes, sir.
And so all you've got left behind is this 1 over here. So can you see that's why it has to be 0, 1? So over here it has to be a 1, and it has to be a positive, and then it makes sense that this is a negative
Negative.
over here. Good question.
Thank you very much.
Cool. Okay, so one thing I wanted to say is if you want another point on this line, all you need to do is take the original rule. So let's say like I take the point x is 4. If I say x is 4, which is probably going to be like down here somewhere. If I put that into my rule, I get 2 times 4 plus 1, which is 9. And so then I can know another point on my line would just be 4, 9. And you can get many other points on this line by plugging in an x value and getting out a y value, as long as you use the original rule. Okay. Now, I've talked a lot, but I think it's good to have a good foundation before we get going. Now, the first question I want you to do today is I want you to take this picture over here. This is a straight line picture. And I want you to find me the gradient between A and B. So this is a little bit of a throwback to our last module. I want you to find me the equation of the straight line that is here. So y equals something. And I want you to find me the x-intercepts and the y-intercepts. The gradient formula, we learned this in the last module, but I'll put it up to start with. Get me my gradient, and then you can pop it in the chat. So off we go. And for those who are feeling comfortable, you can go ahead and try all 3 of these smaller questions. Okay. So now you've told me that the gradient is 3, which means the straight line that I'm after must have this format, but not +1. I don't know why I'm writing +1. I don't know what C is. And what we learned in the last module is that we can choose a point on the line and sub it in to help me find C. And I normally choose the easier of the 2 points. So use the point 2, 1 and sub it in and find me the C value now. So everyone is using this point that's on the line, and you're finding me the mystery C value so I can work out the equation of this line here, which I'm after. Nicely done, Asa. Nicely done. So for me, and from what I'm seeing from Sulilele and Tando and Lilita, we all agree that the equation of this line should be -5. So we know this is 3x minus 5. Now, lastly, I want you to find me the x-intercepts and the y-intercepts of these 2 lines. Now, you can see kind of roughly what the y-intercept is, but the x one, it's going to be hiding somewhere down there. And so I want you to use what you learned earlier on to find me the x-intercept and the y-intercept. You're doing well, though. You're doing very nicely. Go team. So remember what we said above, to find the x-intercept, you make y0, and to find the y-intercept, you make x0. So what are the coordinates of those two going to be? Suppose the y-intercept is easy because you can kind of see it here. And remember, you're using this rule here. There we go. Oh, I'm running out of space here. Okay. We should be getting 3/5 0 or 0.60 for my x-intercept and 0 minus 5 for my y-intercept. Give me a thumbs up if you're feeling okay with things so far. Give me a thumbs down if you're feeling unsure. Just want a quick little vote from the people of the room. So make sure, everyone, that you've got your coordinates the right way around. So the x-intercept has to have a y value of 0. And the y-intercept has to have an x value of 0. Okay, so Vatsal, I'm going to take a question from you now, but while that is happening, let me just quickly zoom and make this. This is the next question I want everyone to do. So I want you guys to do the same thing that you just did now on the second line. So I want you to find me the gradient, which I'll call m. I want you to find me the equation of the line. And then I want you to find me the x and y intercepts. Now, I'll take that question. Can we unmute Tegovaso and we can talk about the question? Yeah.
Good afternoon, sir.
Hey.
So I wanted to ask for the x-intercept. How did you get 3/5? Because when you transpose 5 to the other side, it's positive.
I think you have absolutely, I should have had, the 3 comes across. You should have had 5/3. Yeah.
Yes.
Thank you so much for spotting that. I obviously had a moment where I was concentrating on too many things. Love it. Shout out to you. Okay, next question. So let's try and do the same thing. And then you can pop your answers as you go into the chat. And the 2 points are 1, 1 and 2 minus 5. So just to focus on what I'm doing, I find the gradient using the 2 points, and then that gradient is what is in my equation of my straight line, but I'm still missing C. And so I'm going to use a point on the line to help me. And I should be getting, let's have a look. I sub this in. So it's -6. So on this side, it's going to become So 1 plus 6 is C, is 7. And the equation of my graph is going to be minus 6x plus 7. Now, if there are any questions, please put your hand up and I'll take them now. Otherwise, try and find me the x and y intercepts while we're waiting. Who else has a question? I saw one a while. Tandumbula has a question. Maybe we can unmute Tandumbula. Can you hear me, Tandumbula? Okay, we'll just give a moment there while we continue. So the first one over there is going to be set up like that. And then to find the y-intercept, I need to make the x0. Okay. Now let's see if I don't. Yes. Did I lose someone there for? Yeah.
No, she's unmuted now. I don't know if she can hear us.
Okay. No problem. If we can you hear us, Tandumbula? Maybe there's a bit of mix up there. That's fine. I see Onela also has, I'll unmute Onela, or at least try to, and see if she can ask her question.
Hello, sir.
Hey, how's it going?
I'm good. How are you?
Very good. What can I do for you?
Sir, I don't understand how you find the equation of the line. I only found the gradient, but then I don't understand how you find the equation of the line.
Okay, let me talk you through that. First of all, once you've got the gradient, do you understand how I got the -6 down here?
Yes, we found it on the gradient.
Perfect. Now all straight lines have a c, so mx plus c. You've got the m. All I need to do is figure out the c. And what I'm doing is I'm taking a point on the line. I choose the simplest point, and I'm subbing it into this equation. So the place I'm going to is look over here. How I now have a 1 where the y is, and then I have another 1 where the x is. And they're coming from that point.
Yes.
And then can you see how when it comes across, it becomes plus?
Oh, yeah. Okay, I understand.
Perfect, perfect, perfect. All right, everyone. So I think that we've done well in finding the equations of lines, finding the standard form, and finding the intercepts. Now, and these are bread and butter. And the good thing is, finding the x and y intercepts also works for other types of functions that are more curvy. And so that's a good bit of basics. I like what I'm seeing in the chat. I'm seeing life in the chat there. Okay, what I want to do now is I want to take a brief break before we move to part 2 of the lesson. And so I want everyone to just stand up for a second. And I want you to join me in being a bit, I don't know if silly is the right word, but, you know, just not being too self-conscious maybe is the way of thinking. And let us, what I want you to do is I want you to do whatever, I find my, where's my gallery gone? It's like extreme multitasking on my side. What I want you to do is I want you to stand up and I want you to do whatever is relaxing for you. So I like doing this. I like to just swing my arms. So that helps me unwind a little bit, literally, I suppose.
Join us in the stretch, guys.
And then what I do is I like to roll my shoulders a little bit because when I'm hunching over, my shoulders get tense. So I stand up nice and straight, and maybe I take a couple of deep breaths. And I just breathe out, roll my shoulders a bit more. Oh, there we go. So I'll do that. And I'll shake out my arms. Maybe I'll shake out my legs. And then let's stretch our shoulder blades. I can feel my body saying thank you. Maybe it's an old person thing, who knows? But either way. Okay, so that's that stretch, and then tricep stretch. Then switch. And then swing those arms up. Okay, and then let's have some heart rate raising activities. So let's do jumping jacks. We're going to do 15 today. So for those who are new, basically a jumping jack is like this, and your feet are also moving apart at the same time. And let's go. 1, 2, 3. 2, 3, 4, 5, 6, 7, 8, 10, 12, 13, 14, 15. I feel like I'm getting fitter. Woohoo! 15. There we go. And we are hopefully feeling human again. And where are we here? Let's do a little brain break. So again, we like a bit of Math 24 for our brain breaks. So today we're going to do some of that. See if you can make 24 using these two cards. Well, first do the red one. Can you make 24 using just the red card? Use each number once, only plus, minus, times, divide, and brackets. See if you can do it. Who would like to give me their answer? Who has a? So 6 times 2 times 2, and then you also have to go, you have to use up the 1, but I think we can all see we do that. Also, we can also go, it seems 6 minus 2, which is 4 times 6 times 1, which is 24. Or another one I see here is 6 plus 6, which is 12 times 2 times 1. Okay, so red has been mastered. Can we do the blue one? Lolita's got it as well. Okay. I think the blue one is a little bit trickier. Oh, I'll give you a hint. What's 2 times 3? How can we use 2 times 3 and then you use the remaining ones to get to 24? So we've got a 2 and a 6 left. Ayanda, let's have a look. So you're right, you go 6 minus 2 is 4, and then 4 times 2 times 3 would give us 24. Yeah. And more,
Nice.
there we go.
Done, guys.
Well done, everyone. That was good. Okay, so we've had our bit of unwinding. Hopefully your brain has forgotten about straight lines for a bit. And then we're going to come back now and we're going to keep moving forward. Okay, what I want to do now is I want to go the opposite direction a little bit. And I want us to draw a straight line. And I want you to, but let me choose something that's a bit harder because I think you guys know what's going on with this. Let's do this one, the second one. I want you to draw 2 graphs on the same set of axes. So these are 2 straight line graphs. And in order to draw straight line graphs, we have to find 2 points And the 2 points that we most often choose are the x and y intercepts. So for each of these, I want you to find the x and y intercept. And then when you're done, I want you to plot them on a Cartesian plane and label them and draw them like you would for kind of the test exam. Okay, so over to you guys. You can ask me questions as you go, but I want you to draw these 2 straight lines by first finding the x and y intercepts, then plotting them, and then drawing me a straight line. So I like to do this just to remind me how I find them. So once you've got your points, then I want you to plot them on a graph and see what it looks like. I'll draw mine in a moment or two. Okay. I did that probably a little bit too quickly for everyone to be able to do it. But I just want you to have a look at the way I've done this, how I've kind of done the working out first for both graphs, and then I have my points. And what we notice is that the 2 points actually meet here. Does anybody know the special name for this point where 2 points collide? Does anybody know what that special word for that is? You can put your hand up if you do, or you can put it in the chat. What's it called where 2 things collide? What's the special name we use? Let's unmute Bongacha.
Hello, sir.
Hey, what's that point called?
It's called the equilibrium.
It is an equilibrium point, or you could also call it, have you heard of the intersection point?
Oh, yes, sir.
So equilibrium or intersection point. Perfect.
Yes.
Now, what is the intersection point for these 2 lines? What's it going to be, the intersection point?
I think it's 0.
It's 0 on the X, and on the Y?
On the Y, it's 4.
4. Perfect. So that's our intersection point, which happens to also be the Y-intercept. Fantastic.
Yes,
Okay, now, what I want us to do is, I want us to do another example like this, except I'm giving you 2 straight lines, but I'm giving you them in slightly different forms. So in this case, this is a straight line, which is not written in standard form, but it's still a straight line because X and Y's powers are 1. And then this funny one over here, f of x equals 2x minus 5, this is what we call f of x notation, but it is the same as writing y equals 2x minus 5. It means the same thing. So I want you to do the same thing that you did in this previous example for these 2 straight lines, and also draw them again on the Cartesian plane after doing the working out. Okay, and then while students are doing that, if there are questions about my first example, I want you to raise your hand and I'll answer the question as best I can. Okay, so let's go to Kurozo. Let's unmute Kurozo. Can you hear me, Kurozo? There we go. Yes.
So if we wanted to find the x-intercept or the y-intercept, if we substituted another point instead of the point that is substituted, is it going to give us the same answer, or are we going to get a different one?
Okay, if you want the y-intercept, the x coordinate has to always be 0. It doesn't matter if you have a cubic function, if you have a parabola, hyperbola. If you want the y-intercept, you have to use x as 0. If you want the x-intercept, you must use when y is 0. So that will work whether it's in standard form or not in standard form. It will still work, but you need to use that. If you get what we did earlier when we put an x value in and got out a y value, that will give you other points on the line, but it won't give you the x and y intercept, which is normally what we look for. So it's a good question. You could get another point. You just won't get the intercepts. Does that answer your question? Or
Yes. Yes, sir.
sort of answer? Okay. Okay, let's draw this second straight line graph. Let me actually move this so there's more space. I'm going to call this equation 1. And I'm going to call this equation number 2, just to make life easier. Let's make this a bit bigger. Now, I'm probably doing a bit of, not everyone will always do the writing down the points every time, but it's just nice for you to see the whole, and again, I'm putting this in here. You don't have to put that in, but it's, again, I just think it's nice for everyone to see exactly what I'm doing as I go. Okay, so now I've got 0, 4. It's up here. And then I've got 2, 0, which is here. And then I've also got, I must label my points still, but I've got 0 minus 5. And I've also got 2.5, which is going to be here. And let me make sure I label. So if they don't say you have to label with a full coordinate point, you could just write in the values like that. Depends on what the labeling asks for. And then here it was 4, and there was 2. But I need to give the equation. So this was the equation F. And then this one over here, sorry, that wasn't F. That was the original one. 2y plus 4x equals 8. And this one over here was F. So when you draw graphs, you have to have your x and y axis, you have to label your intercepts, and you also have to label the graph. If you're given the graph in f of x notation, what's quite nice is you can just label it with an f. You don't have to write this whole gedunte down here. Give me a thumbs up if you're generally following what I'm doing. Give me a thumbs down if you feel unsure or uncertain, or you've lost me, or I've lost you on a step. Just want a quick little bit of feedback. Okay, now, the final thing for today is, if you notice in the previous question, it was very easy to see what the intersection point is. In this question, it's not as easy to know exactly what the intersection point is. So if you look at that red dot, can you see that it's where the two lines meet? And I want to suggest that we need a method or a process for finding whatever two lines or functions intercept with each other. And so in the last 2 minutes, I just want to show you the method, because we're going to start this in the beginning of the next lesson. And so it's a nice chance for me to just get this example. Okay. If I look at the two, in fact, yeah, let me do this. Actually, in fact, you know what? Let me show you on a different example. It's going to get too complicated if I do it on this one here. I see there's quite a few thumbs downs there. Are there any questions you'd like to ask before I squeeze in this example before the next lesson? I'm going to check. Okay, so to find intersection points, and this is going to be something we start in the next lesson, to find intersection points where two lines meet, all you need to do is make two equations, the two equations equal to each other. So, and the way you do that is you make sure that they both have the same variable by itself. So in these two equations, these are two straight lines. I'm not going to have time to draw them, but you can see the y's by itself. If you want to find where these two lines meet each other, all you do is you write 2x plus 1 equals minus x minus 5. And that will give you the place where they meet each other, the intersection point. I want you to solve this equation for me. So find me the value of x and y such that it satisfies this equation. And all that means is solving this equation here. So over to you guys. Kagotso, you don't have to put it into standard form before substitution. You can if you like, but you don't have to. Okay, so let's just finish today with finding the solution to this equation. For some reason, my screen just flicked over into... Oh, what's going on? There we go. Now, again, just to make sure no one's confused, I'm not referring to the previous example. I'm just squeezing in one more thing before we finish. Oh, what happened there? I'm just squeezing in one more example before we finish today. And that's these two random straight lines over here. And I'm just making sure we understand for the next lesson. So if I bring the x across, I get 3x equals minus 5 minus 1 minus 6. And so the x coordinate of my intersection point of these two lines is minus 2. What's the y coordinate going to be? And how would I get it? I'm probably going to use the easier of the two ones here. It says y is equal to 2 times x plus 1. So I go 2 times minus 2 plus 1, and I should get minus 3. And so the intersection point of these two straight lines would just be minus 2, minus 3. Now, we will definitely practice that more in the next lesson, but I just thought it's nice for you to see that at the end of a lesson so you have some time to think about it before the next lesson. And so what have we done today? Today, we've looked at how straight lines are built. We've looked at how do we find the intercepts. We've looked at how do we draw straight lines. We've looked at, at the end, we've looked at how do we find intersection points, which we'll continue with in the next lesson.